Hey friends, hope you're doing well. Today I'd like to give you an introduction on how you can do transfer learning using TensorFlow Hub. Now, for those of you who do not know what transfer learning is, basically it means that we use a pre-trained neural network which has already trained, so we can save our time and do not have to do it ourselves, and then we just fine-tune it on our specific problem. The way it works is the following. At first, of course, as always, we need a dataset. In this case, I'm using here an image dataset, which has different kinds of food classes here. And I can download it using this URL, and then I unzip it here. And this just has a train and a test directory, and then there is food, like a steak, for instance, ice cream, and other kinds of foods. Just images of those inside those two folders. Now I extracted them, and now let me scroll down. You can see here pizza, ramen, fried rice, and so on. So these are the food classes. And then I imported TensorFlow here, and we also imported the image data generator. The image data generator class allows us to specify what we want to do when we load the images. This is what we do here. We specify that we want to rescale our images. So because neural networks are very prone to the scaling, so it's always good to rescale them by dividing them by 255.0 in this case, to have the array actually with values between 0 and 1. That's the goal behind of that. Because we have the color scale from 0 to 255, and that's the reason why we divide by this. And because we want to have it as a float, that's why we divide by .0 in here. We specify a shape and a batch size here. So the shape is the shape. We want to reshape the images. So because the neural network expects them in a specific shape. And that's why we say 224 pixel width and height, and then also a batch size of 32. And these are the hyperparameters we're going to use when we then use the train data generator. So we specify here, we instantiate it, and then we say the flow from directory, and we just put in the train and the test directory. We specify the batch size here and also the target size. So the images gets reshaped so they have the same size, 224 by 224 by 3 color channels, right? Because they are colored images. The mode is categorical because we have more than just 2 in this case, or more than just 1 food class. In this case, that's why we have a category here. And then you see that we have here images to 10 classes in this case. And then we import the hub, and that's a main point here in this video. We import TensorFlow hub, and then also the keras layers. Then when you go to the hub, you can find here pre-trained vectors. In this case, it's ResNet, and which is this one here. You can go to the URL, and you'll find that you just need to copy the URL path in order to use this pre-trained model. In this case, it's not a complete model because we only use, let's say, the most crucial layers of the model, which has been trained, in this case ResNet. And then we specify here a function, in this case it's this create model, and we put in the URL, which comes from here, and also the number of classes, which in our case is 10, because we got 10 food classes. And then we use the hub.keras, in this case, this class here from the hub, and put in simply the URL and specify the input shape. And our shape here in our case is 224 by 3 color channels. We say we don't want to train it because it's pre-trained. And then we just use a simple sequential model here where we put in our feature extraction layer, which is this one here. And then we also add an additional layer, which is a dense layer with 10 neurons because we have 10 classes. And because we have 10 classes and it's categorical, that's why we put in activation as softmax here. And then we return the model, and then we just need to actually instantiate that. So actually call the function, not instantiate. But let's say model equals create model. We put in the URL, which is coming from, where is it? Here, this one. And then we just download the model here, and then it's available. You can see that when we call summary, we got here our model with just the keras layer, but under the hood, this hub layer, of course, has multiple layers, right? We just use the pre-trained one here, and then just stack on top of it our own dense layer. And then you also can see here, there are a lot of parameters, more than 23 million. But for our sake, we only need to train the last dense layer, which only contains, in this case, then the trainable parameters, which in this case is 20,490. So much less than the 23 million, right? And then we compile the model as always, and then we just call the fit method here and store it in the history, and we put in the train data generator, and the validation set, in this case is a test data generator. And then we say, in this case, there are 4 epochs, and then we just run the model in this case, and you can see that the accuracy, at first it's very low, but then it rises. And of course, we could train it for longer, and then you probably get a higher accuracy score than I do here. But of course, for our sake, not only this accuracy on the training data, but also keep in mind this value accuracy is much more interesting to us than the training itself. And then of course, finally, when we apply this to real world data, then of course, the real interesting part begins. So then here we have, I just showed here with S, in this case in stake folder, what kind of images are there. So you have actually a reference here, and you can see if I call this with the image here, and I can there see that this, for instance, is one of the images which is in one of those folders, which the model tries to predict. And for the prediction part, just in case you want to predict a certain image, you can then read this, for instance, using CV2 in here. You need to resize it so it has the right shape. Also make sure if it's only one image that you expand the axis, otherwise the model will complain because the first axis is not specified, and then you just run model.predict, and then you get a prediction, which in this case looks like that, and you can simply call with the argmax simply what is the prediction, and prediction in this case is 5. So that's how it works. So this allows us to use the TensorFlow hub to use really sophisticated models and simply stack our own layers on top and apply this on our own project. So hopefully that was interesting to you. If so, please give this video a like, also share it, and please don't forget to subscribe to the channel. Thanks a lot, it means a lot to me. Best regards and take care.